Imagine a world where your gadgets are no longer hard, flat boxes. Instead, they can bend, stretch, and wrap around things just like a sticker or a piece of tape. This isn't science fiction, it's the amazing world of flexible electronics. We are seeing these incredible devices pop up everywhere in our daily lives. Think about smart wristbands that track our steps and heart rate while we exercise. Or consider smart clothing that can monitor our health while we go about our day. These devices are designed to fit our bodies and our lifestyles, making technology feel more natural and integrated than ever before. It's a huge step forward from the clunky phones and computers we used to carry. These bendy gadgets are completely changing how we interact with technology. For example, medical sensors are no longer big, uncomfortable machines. Now they can be thin, flexible patches that stick to your skin like a temporary tattoo. These patches can monitor vital signs, like your temperature or blood sugar, and send the information directly to your doctor's phone. This means people can get better healthcare without having to stay in a hospital. In another example, smart tags on food packaging can now tell you if your milk has gone bad, just by changing color. All these innovations are possible because the electronics inside can bend and flex without breaking. The secret behind these amazing devices is their ability to be thin, lightweight, and conform to different shapes. Unlike the rigid circuit boards in our laptops and smartphones, flexible electronics are built on materials that are more like plastic or rubber. This allows them to be rolled up, twisted, or even folded. This flexibility opens up a whole new universe of possibilities for where we can put technology. We could have interactive wallpaper that changes with our mood, or solar panels woven directly into our backpacks to charge our devices on the go. The goal is to make technology disappear into the world around us, making our lives easier and more connected. But for any of these amazing gadgets to work, they need one very important thing: power. And that's where the biggest challenge lies. A device is only as good as its battery, and these new flexible electronics have very special needs. They require a power source that is just as thin, flexible, and safe as the device itself. A normal, chunky battery from your TV remote simply won't do the trick. The battery must be able to bend and move with the device without losing power, or, even worse, breaking. This has pushed scientists and engineers to completely rethink how we design and build batteries for the future. Let's think about the batteries we use every day. The ones in our phones, laptops, or even toys are usually hard, rectangular blocks. These are called rigid batteries. They are designed to stay in one shape and are packed tightly into a solid metal or plastic case. This design works perfectly fine when your device is a solid, flat object. The battery sits securely in its compartment and provides a steady stream of power. It's a reliable design that has served us well for many years, powering everything from our first portable music players to the powerful smartphones we carry in our pockets today. They are great at storing a lot of energy in a small space. However, these traditional batteries have a big problem when it comes to flexible electronics. Imagine trying to wrap a solid brick around your wrist. It wouldn't work, right? The same is true for rigid batteries. If you try to bend or twist them, they will break. Inside these batteries are delicate layers of materials and a liquid electrolyte, which is a special chemical soup that helps electricity flow. If the outer casing is bent or punctured, this liquid can leak out, which can be dangerous and cause the battery to stop working. This makes them completely unsuitable for wearable devices that need to move with our bodies. Another issue is their size and weight. Traditional batteries are often the heaviest and bulkiest part of any electronic device. For a smart patch that sticks to your skin or a piece of smart clothing, you need something incredibly lightweight and thin. A heavy, bulky battery would make the device uncomfortable to wear and impractical for daily use. The goal of flexible electronics is to be almost unnoticeable, blending seamlessly into our lives. A big, clunky power source completely defeats that purpose. It would be like wearing a tiny, comfortable sensor that is attached to a big, heavy power brick. So it's clear that to power the future of flexible gadgets, we need a whole new kind of battery. We need a power source that can bend and stretch without breaking, is super thin and lightweight, and is completely safe to have next to our skin all day long. This challenge has sparked a revolution in battery technology. Scientists are no longer just trying to make batteries that hold more power. They are now trying to make batteries that can twist, fold, and stretch. This has led to some incredibly creative and innovative designs that are pushing the boundaries of what we thought was possible for energy storage. To create batteries that can bend, engineers had to get creative and use new materials and designs. One popular approach is to make the battery incredibly thin, almost like a piece of paper. These are called thin film batteries. They are made by depositing ultra-thin layers of battery materials onto a flexible surface, like a thin sheet of plastic. Because each layer is so thin, the entire battery can be easily bent or rolled up without damaging the internal components. It's like how you can easily bend a single sheet of paper, but it's much harder to bend a thick book. This design makes them perfect for devices like smart labels or powered cards. Another clever idea is to change the structure of the battery itself. Some designs look like a tiny accordion or a snake's spine. These batteries have a wavy or kirigami structure, inspired by the Japanese art of paper cutting. The components are connected in a way that allows them to unfold and stretch when the battery is pulled, and then fold back up when it's released. This means the battery can be stretched to more than twice its original length, without breaking or losing power. This kind of design is ideal for electronics that need to be stretchy, like smart fabrics that move with your body as you run or exercise. One of the biggest breakthroughs for safety is the move away from liquid electrolytes. As we mentioned, the liquid inside traditional batteries can leak if the battery is damaged. To solve this, scientists have developed solid-state batteries. These batteries use a solid material, like a special polymer or ceramic, to move energy around instead of a liquid. This makes them much safer because there's nothing to leak out. A solid-state battery can be bent, or even cut, without causing a fire or a chemical spill. This is incredibly important for devices that we wear directly on our skin or implant inside the body. Of course, creating these futuristic batteries is not without its challenges. One of the hardest parts is balancing flexibility with power. Usually, the more energy a battery can store, the thicker and more rigid it becomes. Making a battery that is both paper-thin and powerful enough to run a device for a whole day is a huge engineering puzzle. Another challenge is cost. The new materials and complex manufacturing processes can make these batteries expensive to produce. Scientists are working hard to find cheaper materials and simpler ways to make them, so these amazing devices can become affordable for everyone. The real-world applications for these flexible batteries are truly exciting and are already making our lives better. Think about a smart wristband, like a fitness tracker. To be comfortable, it needs to wrap snugly around your wrist. A flexible battery allows the entire wristband to be slim and follow the curve of your arm, making it something you can wear 24/7 without even noticing it's there. The battery bends every time you move your wrist, yet it continues to safely power the sensors that track your steps, sleep, and heart rate. Without a flexible power source, these devices would be much bulkier and less comfortable, like wearing a miniature box on your wrist. Another great example is in the field of medicine. Imagine a patient recovering from surgery. Instead of being hooked up to loud, bulky monitors, they can wear a soft, flexible patch on their skin. This patch contains sensors powered by an ultra-thin, flexible battery. It can continuously monitor their vital signs and send alerts to a nurse's tablet if there's a problem. This makes the patient more comfortable and allows them to move around freely, which can help them recover faster. The safety of solid-state flexible batteries is critical here, ensuring that there is no risk of chemical leakage or irritation on the patient's skin. Even simple things like shipping and logistics can be transformed. Smart labels powered by tiny, flexible batteries can be attached to packages. These labels can track the location of the package, monitor its temperature to make sure sensitive goods like food or medicine don't spoil, and even detect if the package has been dropped or opened. Because the battery is as flexible as the label itself, it can be stuck onto any box, envelope, or container, no matter the shape. This gives us a much smarter and more reliable way to track goods as they move around the world, reducing waste and ensuring quality. Ultimately, the advancements in flexible energy storage are the key to unlocking the full potential of next-generation electronics. By creating batteries that are thin, bendy, safe, and powerful, we are paving the way for a future where technology is more seamlessly integrated into our world. These innovations will lead to smarter medical devices that improve our health, more comfortable and capable wearable gadgets that enhance our daily lives, and countless other applications we haven't even dreamed of yet. The future isn't just smart, it's flexible, and it will be powered by batteries that can keep up with our ever-changing world.